With this project, you can hear the sound echoing when you wear headphones. I'm going to push keys on the keyboard and listen carefully. You can clearly hear the different notes echoing when I press the keys. The RV resistor controls how much echo there is. Right now it's at the maximum setting, and the RV3 resistor controls the volume. It's on the highest volume, but if you're actually wearing the headphones, you should start at a lower volume and then gradually work your way to a comfortable setting to reduce the risk of hearing loss or simply hurting your ears. Now you can also include the photoresistor, and when there is light on it, the sound will be different, as you can tell. Waving your hand over the photoresistor will change that sound even more. And I should quickly note that because the audio jack is not connected by the right output, you're going to only hear sound out of the left headphone. And there you have it. Project 51 will only be an explanation, because for this project you'll need a stereo speaker, which I do not have. You'll lay it on the floor, and the larger the speaker the better. Then you'll put your hand on the stereo speaker and turn up the volume, and then you should hear the speaker vibrate. You should feel the speaker vibrate. You can also try this with paper, with a balloon, and also with another small material like salt or glitter. But make sure you get your parents' permission before you do that. You'll learn about how sound can make things jump up or bounce up and down. And you could also do Project 52 and use this circuit to make sound to connect your stereo speaker, and then push keys on the keyboard to see whether or not to see the whatever material is on the speaker vibrate because of the sound from the keys. Here I am going to give a direct demonstration of the adjustable resistor, which in this project will control the color LED. Turn on the slide switch, and you can move the lever on the adjustable resistor to make the LED brighter or dimmer. The RV controls the amount of current that flows through the circuit. Resistors like this one are used to control or limit the flow of electricity, while higher resistor values reduce its flow. The LED itself has a built-in resistor because otherwise current from the batteries will ruin it. And resistance is measured in ohms, as you may know from previous projects. The adjustable resistor can be set for as low as 200 ohms or as high as 50,000 ohms or 50 kilo ohms. And this is how a dimmer switch in your house works. I'm going to demonstrate the R1 and R3 resistors. I'm going to replace the 3-snap wire with the R1 resistor, which is rated at 100 ohms. And it's going to have little effect on the limiting of current because the resistor with the higher value in a circuit will always dominate. In this case, it's the adjustable resistor, since the adjustable resistor can be as high as 50,000 ohms. But the R3 resistor will dominate and limit the current significantly when the RV lever is at lower settings. But when the RV is at higher ones, it will dominate over the R3 resistor, which is rated at 5.1 thousand ohms. And there you have it. Here, I will control the brightness of the color LED using the RV3 resistor, which is even more powerful than the RV adjustable resistor. Turn on the slide switch, and at the lowest setting, the RV3 resistor has a value of 200 ohms, but on the highest setting, it is rated at 500K or 500,000 ohms, and therefore the color LED is off because the resistance is too great for any current to flow through it. This project specifically demonstrates the purpose of the photoresistor, which is a light-sensitive component that controls the flow of electricity according to how much light is shining on it. When there is a lot of light on the photoresistor in this application, resistance decreases and the color LED comes on. But when I remove the light, electrical resistance increases and the color LED turns off. The resistance in the photoresistor varies from about 1,000 ohms to nearly infinite. And this kind of component is used in applications such as street lights, which come on when it gets dark or during a severe storm. In this circuit, I have the NPN transistor, and while in the previous project, the photoresistor directly controlled the brightness of the LED, here, current through the photoresistor has to be amplified by the NPN transistor before it can go to the color LED. And therefore, it's much more sensitive to light. You really have to cover the photoresistor for the color LED to turn off, and even then, it may not work. I inserted the RV3 adjustable resistor, and I can use it to try to reduce the brightness of the color LED. Because of the NPN transistor, there's very little difference in brightness no matter what setting of the RV3 resistor I use. You might as well view the LED in a dark room, and then you may notice a slight difference in brightness. You can compare this to Project 55, in which the color LED was dark during much of RV3's range, but now it's the other way around due to the NPN transistor amplifying the current through the RV3 resistor. Project 59 is going to be an explanation only, but a lot of you are probably familiar with what it is about. And in this project, you will create a makeshift telephone out of cups and string. And you can take a while to look at the instructions on how to make and demonstrate and use this telephone, and you and your friends could have a lot of fun with it. You can also learn how telephones in general work.